Dear students, this is Professor Anand working as an assistant professor at St.Joseph College of Arts and Science, Cuddalore. In this video, we are going to discuss about the ligand substitution reactions in octahedral complexes. Okay, so these ligand substitution reactions mainly classified into SN1, SN2 and SN1CB. First, let us start with the SN1 reactions. So these SN1 reactions, you might have heard it from the organic chemistry. Okay, so the same or some similar type of aspects can also be discussed here for the reactions and the ligand substitution reactions in the octahedral complexes. So SN1 means that nucleophilic substitution unimolecular substitution reactions, and you know that it is generally a dissociative mechanism. It follows dissociative mechanism. In this mechanism, first the reactant metal complex dissociates. Okay, you know that MLN first dissociates into ML minus 1, MLN minus 1 plus L. It is slow dissociation step. So in this step, the ligand to be replaced is lost from the complex. Then the vacancy created in the coordination sphere is taken by the new ligand. Okay, it is undergoing fast step. So let us discuss the characteristics of this SN1 mechanism. First thing, only one species, that means MLN. Okay, only one species is involving in the formation of activated species. So MLN is involving in the formation of activated species. So this activated species formation step is known as slow step. It is known as slow step. In the second step, what will happen? The activated species undergo fast reaction with the incoming ligand Y. Yes, this is identified here. Okay. Then the activation energy for the first step is high, and that for the second step is low. Okay, it is why? Because it has to dissociate one ligand from the complex. Okay, it is not an easy step. Okay, because already MLN is a somewhat a stable complex. Okay, so from this stable complex we cannot easily remove the one of the ligand. So for this the activation energy may be very high. Okay, the rate of overall reaction depends on MLN only, because the dissociation step is involving the dissociation of ligand. It is slow. Okay, as soon as the activated complex is formed, the incoming nucleophilic ligand can easily attack the activated species. Therefore, the overall rate, first let us take the rate. Overall rate depends only on the MLN. Okay, that means complex, but not with nucleophilic ligand. Okay, therefore the overall order is purely depending on only MLN. Okay, that means first order, but not with the nucleophile, zero order. Therefore 1 plus 0 is It is 1, that means first order. Okay, in the formation of the activated complex in an SN1 reaction, the coordination number of the metal is decreased by 1. Okay, because here it is involving that only one ligand is removed here, only one ligand is removed here, therefore the coordination number of the metal is decreased by n to n minus 1. Okay, so let us come to the final characteristic. Therefore the rate can be written for this SN1 reaction is, the rate constant is K1, since it is involving the first order reaction, therefore we are writing K1 and concentration of the given complex. Okay, so let us give some example for this SN1 reaction. Chromium hexa aqua complex, which is following slow step, and Cr H2O 5 times 3 plus H2O. Okay, it is the phi coordination, it is the phi coordinated intermediate. Then if you introduce one Cn minus ligand, what will happen? It will give Cr H2O 5 times Cn2 plus. Therefore, the rate of this entire reaction is purely depending on only the given hexa aqua chromium complex. So, K1 Cr H2O 6 times 3 plus. It is first order in nature. Okay, therefore, according to this mechanism, the rate of reaction is directly proportional to the concentration of this Cr H2O 6 times 3 plus alone. Therefore, it is clearly saying that it is independent of the concentration of nucleophile. So, that's all about the SN1 reaction. Then, let us go for SN2 reaction. What about the SN2 mechanism? We know that SN2 mechanism is nucleophilic substitution by molecular reaction. By molecular reaction, and since SN1 is dissociative mechanism and SN2 follows associative mechanism, as you have studied in the organic chemistry, associative mechanism, it follows associative mechanism. The general picture for this mechanism is, if you take MLN plus nucleophile Y, okay, nucleophile Y, then what will happen? The slow association will be taking place. Slow association. Okay, after that, the incoming nucleophile will be attached with this central metal atom. Therefore, one ligand must be replaced, and it should be it should give the product in this way. It is fast reaction. It is the fast. Second step is the fast step. First step is slow association. Second step is fast formation. Okay, let us discuss some characteristics of this reaction. In this reaction, two species MLN and Y means nucleophile are involving in the formation of the activated step. Both of them collectively interacting and participating in the formation of activated complexes. Okay, so in the second step, in the second fast step, the activated complex loses a ligand and the new ligand Y becomes, okay, here, and the new ligand Y becomes a permanent part of the molecule. The rate of overall reaction depends on both MLN and Y. Okay, because both of them are coming together in order to form ml and y, and since it is involving in the slow association step, the reaction is first order with respect to mln and first order with respect to y. Okay, therefore the overall order is second order 2. Okay, so therefore we can write the overall order as K2. Why we are writing K2? Since it is following the second order mln 1 and y power 1. 1 plus 1 is 2. Therefore it is second order. That's why it is known as bimolecular reaction. Okay, this mechanism can be illustrated with the hydrolysis of this following complex NH3 CONH3 5 times Cl 2 plus. Okay, CONH3 5 times Cl is now going to interact with the water molecule, water as a nucleophilic ligand, and we know that it is a slow step. So during this slow step, what will happen? The slow association of water to the cobalt pentamine complex. So CONH3 5 times Cl and water. Okay, so it is the 7 membered 5 amine 6th chlorine 7 water 7 membered transition state. It is a 7 membered transition state. So during the formation of 7 membered transition state, what will happen? As soon as it has been formed, there should be the compulsion of relieving the intermediate complex or transition complex at a transition state. Therefore it forms CONH3 5 times H2O 3 plus complex. Therefore the overall order can be written for this SN2 is rate is equal to K2, since it is a second order reaction, cobalt NH3 5 times Cl 2 plus as well as water ligand. Therefore, the expectation that a reaction would occur exclusively either by SN1 mechanism or by SN2 mechanism is not realistic. But in a reaction, the attachment of Y to metal, okay, Y here is nucleophile, and metal is M stands for metal, and the release of ligand from metal can be simultaneous. So in addition, the activated species cannot be directly detected. Okay, so but in organic chemistry we can easily detect, but it is possible, there is a possibility of detection of intermediate, but it is involving some difficult steps. Okay, dear students, I hope you might have understood SN1 and SN2 reactions which are involving in the octahedral complexes of the coordination complexes. Let us meet in the next video. Thank you.